Okay, today we are going to do a case study regarding on how to open a tire bolt. Good morning. Today we are going to discuss about torque or moment of force. Torque basically means that turning effect produced by the force when you are applying a force on a certain substance, they might turn due to that force. So basically that is what torque means. Okay, today I am going to do a case study about how to open the tire bolt using the lever arm. The objective for our findings is we attempt to understand the formula units and its calculation, which is included in our case study for opening the tire bolt. Secondly, we attempt to understand the relationship of force and the length of the lever arm, which we are going to use to loosen the tire bolt. Examples: the distance which we needed and the radius. So it all needed to be considered for its calculation and the relationship of the force.
Good day, doctor. My name is Karthik, son of Ilango. My metric number is B0918100136. I'm a second year student in BMMM section 2. Okay, today I'm going to explain about the part of calculation in the system. Okay, first I explain the situation. The situation is we are going to fix a flat tire by removing the bolt using a wrench. Okay, I simplify the situation with a diagram. Okay, this is a wrench, this is the bolt. Okay, to remove the bolt, so what we're gonna do is we're gonna apply a force over here. So this is the direction of the force. So this will be the point of application of force. Okay, this is the direction of the force exerted, so this will be the point of application of force. Okay, once the force is exerted on this direction, the bolt will start to rotate or twist. So at this point the bolt will start to rotate. So this is the axis of the rotation. This is the axis of rotation. When the force is exerted, when the bolt will start to rotate, there will be a torque. The bolt will start to rotate at this direction, and there is a torque in this system. So now we are going to calculate the torque. Okay, this is the FBD of this diagram. Okay, this is the axis of rotation. It rotates at this way. The force is exerted in this direction. This is the R. R is the lever arm, length of lever arm. How long is the lever arm? Okay, now let's see how to calculate the value of torque in this system. Okay, torque is represented with the symbol of tau. Tau equals to R times F. F is the length of lever arm and force is force exerted. Let's say we are applying a force of 100 Newton. Okay, force applied is 100 Newton and the radius lever arm, the length of lever arm is, let's say, 29 centimeter. So we're going to convert it into meter. It will be 2.9 meter. Okay, so this is the situation. Now we're going to substitute the values in the formula to get torque. The length of lever arm is 0.29 multiplied with force exerted 100 Newton. So the value is 29. Newton meter. The unit is Newton meter. The force is Newton. Do not forget the units. The length is in meter, so the unit is Newton meter. This is the value of torque for this system to open to remove the bolt. Okay, now we're gonna see an example for calculating a force in same torque problem. Okay, now let's say this is we are applying a force. This is a different example. We are applying a force at this direction, this way force. Okay, so there will be a angle. Let's say this is the theta, this is the R, lever arm. So let's say the torque is 33 Newton meter. Okay, this is where the bolt starts to break freely. Bolt start to break freely. So the torque is 33 Newton meter. The lever arm is same as this, 0.29 meter, and let's say the theta is 110 degrees. Okay, now we're gonna find F. Okay, what does the torque formula says? Torque equals to R times F. So in this example, in this situation, we are given a angle. So we have to use the angle force. So we have to add the angle force sine theta. Okay, now what we're going to do is we have to substitute the values. Torque is 33 Newton meter and R is 0.29 times F, we don't know. Sine angle is 110 degrees. So we're gonna find the F. So we do the simple mathematics. F equals to tau over R times sine theta. So the value will be 117.8 Newton. This is the force needed. This is how we calculate the force in torque problem. Now we are in the segment of discussion. We're going to discuss about how to make this process, which is fixing the flat tire, to make it easier. In which way we can make this process easier? The only way is force. Okay, let's see. If we apply a greater force, that means the thing is harder. We're gonna do more hard work. It's harder. If we apply force, a smaller force means that is easier. In order to get a smaller amount of force, we have to do some modification to this system. Okay, let's say we remove the same bolt with using a different, that means longer range compared to this one. Let's say this one is just now 0.29 meter. Okay, this is 0.60 meter. The length of the arm. Okay, this is the point where we apply force. Same exactly like this. Okay, this is R1. This is R2. Okay, let's calculate the amount of force needed to open up the bolts. Okay, same like just now. Torque equals to R times F. This one R1 and this one is R2 times F. Okay, R1 is 0.29 times F. Okay, let's say the torque needed to open up the bolt, let's say this is 33 Newton meter. The both bolts. This is the bolt break free. At this torque, the bolt break freely. Okay, let's say 33 Newton, and the force is 33 divided 0.29. The force needed is 113.8 Newton. Okay, for this system, this wrench 0.6 meter times F, the torque is same. So 3 divide 0.60 equals to F. F equals to 55 newtons. So here we can see the difference in the force. If we use a wrench with longer length, the force needed is smaller. So this from this we can see clearly that the length of the lever arm affect the force. Okay, from this system we know that the bolt break freely at the torque of 33 Newton. So the torque is fixed for this system. So this is the formula for finding torque. R, the lever arm times force. The torque is fixed. Now, so the only thing that we can change is R, lever arm, and the force. So we got two ways. Either we increase the R and decrease the force, or increase the force and decrease the R. Which one will be convenient for us in order to get a smaller force? Definitely increasing R, increasing the lever arm, and decreasing the force. If we increase the lever arm, of course we'll decrease the force. We'll get a smaller amount of force.
3.
Okay, now let us put this aside. Now I show you another example. Okay, this is a door. This is the hinges, and this is the holder, the knob. Okay, we open it up this way. Okay, this is the axis of rotation. This is the axis of rotation. Okay, let's say now, let's say I want to open up the door from here. The holder is here, open up. Let's say I need 20 Newton of force to open up the door. This is the position A. Okay, now I change the knob, the holder position at position B. Okay, let's say if I use the same force to open, which is 20 Newton, from here, I hold the holder here and open up, try to open. What is going to happen? Nothing will happen. The door will not be open. This is because there is not enough torque to open the door. This is R2 and this is R1. R1 is greater, the lever arm at position A is greater, so the torque produced is greater to open the door. The lever arm at position B is smaller, and smaller torque is produced, which cannot afford to open up the door. Same goes here. Okay, let's say this is a greater lever, the lever arm is greater, so the torque produced will be greater, so it will be easier to turn the bolt. The lever arm over here is shorter, so the torque produced will be smaller a bit compared to this one, so it will be harder to turn the bolt. Okay, what if I apply force over here? Same like this, nothing gonna happen. If I apply the force over here, smaller, the torque does not enough to turn the bolt. Nothing will happen. We have to put a larger amount of force in order to remove the bolt. Thank you.
My name is Anthony Belayo, anak George. My matrix number is B0911810068, and I'm going to share about the conclusion of our project. Before that, we knew that torque or moment of force is the product of force which is perpendicular to the lever arm that only works in a rotational motion. Torque is the turning effect of the force itself. Based on this torque situation, we understood that the relationship of force and also the length of lever arm, the radius, is vice versa. If the length of lever arm increases, then the force decreases. But if the length of lever arm is decreases, then the force is increases. So it is much harder to push the lever with that situation. Hence, for a conclusion, we should know that from this case study is to understand the torque formula, units, and also its calculation, which is tau equals to R F sine theta, which R stands for radius, F equals to force, and also theta is angle between the force and also the lever. Hence, it is crucial to understand this formula because it is a practical way to calculate the magnitude of the torque. Then, also, in this case study, we need to understand the relationship between force and also length, which is the distance and also the radius of the torque. In this case study, we know that a longer spanner is much effective and easy to use to open the tire bolt, whereby the length and position playing a crucial part in this. And also that a suitable equipment is needed to do a great work and task. This can save our time, and also it is good for safety precaution. It's very reasonable for that. Hence, this is our case study, and thank you.